Hi, so what we're going to be doing today is we're going to be looking at a pattern. And the pattern that we're going to be using is called a matchstick pattern. And I have that pattern here demonstrated to our left. What we're going to be doing is we're going to be creating an algebraic rule for our pattern. And what this rule is going to do is it's going to help us find numbers later on in our pattern. So what our pattern is going to look like later on. So right now, what we need to start doing is creating a table. And in our table, we're going to have the number of squares on our left side and the number of toothpicks that create these squares on our right. So what I have one square, and then I have 2 squares, and then I have 2, 3 squares. So I'm going to go ahead and write that down on my left column. So now what I need to find is the number of toothpicks that are in each square. So for my 1 square, I have 1, 2, 3, 4 toothpicks. For my 2 squares, I have 1, 2, 3, 4, 5, 6, 7 toothpicks. And for my 3 squares, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10. And so what I notice when I look at my table is that on my right side, my numbers seem to be going up by 3. I know that 4 plus 3 is 7, and 7 plus 3 is 10. So I wonder, what's my 4th term? Because I know with patterns that if something's happening, it's going to continue to happen each and every time. So if I'm going up by 3, I know that to get my 4th term, I can continue doing that. So I know that 10 plus 3 is 13. And that means that there are 13 toothpicks if I would create 4 squares. So I know that I could do that, and I know that that's just fine to do that, to go up by 3 each and every time in order to get to the number that you want to get to, the number of squares which you're looking for. But I know something that will make this so much easier, and that is to find our rule. Because what if I wanted to find the 20th term? If I wanted to find the 20th term, I would have to find the 19th term. And to find the 19th, I'd have to find the 18th, and so on and so on. So to make this easier for myself, I'm going to create a rule. And in order to do this, I'm going to break up these numbers. And I'm going to look at 4 first. And I know that I can break up 4 into 1 plus 3. And you know what? I did this on purpose because I know that I have 1 plus 3 here, but I'm adding another 3. So I'm going to go ahead and write that down. 1 plus 3 plus 3. And I can do the same thing for a third 3 squares. I have 1 plus 1, 2, 3. 1, 2, 3, 1, 2, 3. And I know that I can write that down this way. Alright, so let's look at this for a second. What I see groups of 3. So I'm going to go ahead and underline those groups of 3. And you know what? Let's write this down. I have 1 group of 3 plus 1, because that's what I have here, 1 group of 3 plus 1. Here, I have 2 groups of 3 plus 1. So let's go ahead and write that. I got 2 groups of 3 plus 1. Let's see, okay. So now I have 3 groups of 3 plus 1. Alright, and I know when I hear groups, I know that this is the same as multiplication. And multiplication and putting things into groups are something that I am comfortable with and I have done in the past. So what I'm going to do, I'm going to use this different mathematical concept to find my pattern rule. So let's go ahead and write this as if we were writing a multiplication sentence. We have 3 times 1 plus 1. And the reason it's this way is because I have one group of 3. I have one group of 3. Okay, here I have 3 times 2 plus 1 because I have 2 groups of 3 plus my 1. Alright, and here I have 3 groups of 3 plus 1. And you know what I'm noticing? I'm noticing that these numbers right here, which tell us how many groups of 3 we have, those match the number of squares. So you know what I'm going to do? I'm going to create my rule. I now know that 3 times the number of squares, so here I have 1 square, 2 square, 3 squares, number of squares which I want to know, plus 1 will equal to the number of toothpicks that I would like to find. So let's say I want to find how many toothpicks are in 20 squares. So if I wanted to jump down to the 20 sets of squares, how many toothpicks would I have? And because I've created my rule, I know that I can plug in 20 into my S. So let's look. I have 3 plus 20 plus 1. Because I plugged in the 20 for the number of squares. And I know that gives me 61. So what this tells me is that if I have 20 squares, there will be 61 toothpicks in those squares. And I found that out by using my rule. My rule which says that 3 times the number of squares plus 1 will give me the number of toothpicks. Alright, so now that we've found our 20th term, I want us to go back and check to make sure that this rule is correct. So you know how I'm going to do that? I'm going to go ahead and plug in our 4 because we found out by using our pattern that 4 is going to have 13 toothpicks. So if our rule is correct, we know that when we plug in 4 for the number of squares, we should get 13. So let's see if this works. If I have my equation, which is 3 times the number of squares, which in this case is 4, plus 1, this should give us 13. So let's see. 4 times 3 is 12, plus 1 is 13. So we know that our rule is correct. And we know that we could use our rule to find any number boxes that we would like, and it will fit into our pattern. So thank you very much. This lesson can be used is appropriate for 4th grade. Kids start learning patterns starting in kindergarten, but they don't start creating this rule until they hit about 4th grade, and they expand on that as they go up. But this lesson would be grade appropriate at 4th grade. So, thank you. So today we're going to be looking at a word problem and deciding what is happening in the problem so that we can decide on how to solve for the unknown numbers of what we don't know. Our word problem for this first example is, Henry and Cindy have 150 marbles in a jar. 86 of the marbles are Henry's. How many marbles belong to Cindy? So the first thing we need to ask ourselves is, what kind of question is this? Are we joining, separating, comparing, or looking at parts of a whole? So let's see. We're not doing anything to it. We're not bringing anything in or taking anything out. So we know that this is not a joining or separating problem. So we can eliminate those two right off the bat. So what we have left is comparing or parts of a whole. So let's look at what we have. I know how many Henry and Cindy have in all. So we could call that a whole. And I also know how many Henry has. He has 86, which would be our part. And I also know what isn't Henry's must be Cindy's. So that would be our two parts. We have Henry's and Cindy's marbles, which combine into our whole. So this problem is a part-part whole. So let's go ahead and draw our part-part whole diagram. We have this part and this part, which come together and give us our whole. So let's look at our problem and set it up. We know how many problems we have in all. So let's look at what we have. Our problem says Henry and Cindy have 150 marbles in their jar. So this must mean that we start with a total of 150 marbles for our whole. So I'm going to go ahead and write 150 in our whole. To find out how many marbles Cindy has, we need to take away Henry's part of the marbles. So let's look at our problem again. It says 86 of the marbles are Henry's. This must mean that I need to make a group of Henry's 86 marbles. So the first part can be Henry's. We know he has 86 in all. So, to find how many marbles are Cindy's, we need to look at how many marbles are left. Because we do not know how many marbles are Cindy's, I'm going to put a question mark. This is what we want to know. Okay, so let's wrap this back to our strip diagram. We know that these two parts are coming together. So, we need to start with what we know. We know that we have a total of 150 in our jar. And we know that this first part, or one of the parts, is Henry's. So I'm going to call this first part Henry's, and we have 86. And this part is what we don't know. So this is what we need to find. We need to figure out how many marbles of Cindy's make up this part. So let's go ahead and wrap this back to what we know. We have learned our base 10 blocks. So I'm going to go ahead and remind us. We have a flat, a long, and a unit. Our flat's made of 100, our long is made of 10, and our unit is made of 100. So let's go ahead and construct our whole, because this is what we need to start with. And it says for our whole, we have 150 marbles. So let's go ahead. We have 150. For our 50, we need 5 longs. 1, 2, 3, 4, 5. Alright, so now what we need to do is we need to take Henry's part out of our amount, out of our whole. So, we start with our units. Because we have no units, let's go ahead and regroup our long to trade it in and give us 10 units. So I traded in my long for 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units. So our long we traded in for 10 units. Now that we have enough to give Henry, we can go ahead and give him his 6 units because he needs 86 marbles. So we have 1, 2, 3, 4, 5, 6. Those are Henry's. Now that we've done our units, we have to go ahead and do our tens. So we know that Henry needs 8 longs because there's 8 tens and 86. So let's go ahead. We know we have 1, 2, 3, 4. We don't have enough. So what we're going to have to do, we're going to have to regroup our 100, our flat, for 10 longs. So I'm going to go ahead and trade that in for 1, 2, 3, 4, 5, 7, 8, 9, 10. Okay, now that we've regrouped 100 into 10 longs, I'm going to take them all, and now I can give Henry his 8 longs, which will give him 86. So we have 1, 2, 3, 4, 5, 6, 7, 8. Okay, so now this is Henry's. Henry has 86. Now what's left is Cindy's. So let's see, we have 10, 20, 30, 40, 50, 60, 61, 62, 63, 64. So we know that Cindy's part is no longer a question mark. We know that she has 64 marbles. I'm going to go ahead and move that up here because I know that her part of the whole is 64. She has 64 marbles. All right. This activity, this lesson, is most appropriate for 2nd grade. On the vertical alignment chart, it states that students with the ability to represent and solve addition and subtraction word problems where unknown may be any one of the terms in the problem. So in this case, it was Cindy's amount in our part-whole problem. But in 2nd grade, they should be able to do this, and they should be learning this kind of lesson in 2nd grade. So, thank you. Alright, so now what we're going to do is we're going to look at a different type of word problem. Our second problem is, John has 3 pennies, Kennedy has 7 pennies. How many more pennies does Noah have than Kennedy? So, the first question we ask ourselves is what kind of question is this? What are we doing? Are we joining, separating, comparing, or looking at parts of a whole? So let's look at what we have. We know that Jonah has 10 pennies, Kenny has 7. How many more? So what does this tell us when we hear how many more? That tells us that we're comparing. So we know that this is a comparing problem. So what I'm going to go ahead and do is grab our comparing diagram. And in our diagram, this shows us that we have this set and this set. We have our larger set on this side and our smaller set on this side. So, now what we need to do, let's start by finding which one Noah or Kennedy has the larger set. So, since Noah has 10 and Kennedy has 7, we are looking at Noah's 10 pennies because this is the larger set. So I'm going to go ahead and label this set as 10. Next, we need to go ahead and label our smaller set. Our smaller set goes down here. And since Noah's was 10, Kennedy's was 7, we know that the smaller set is Kennedy's 7 pennies. So let's go ahead and label this side 7. So now, since we know that Kennedy has 7, we can label the smaller set as 7. So now that we have our sets labeled, let's remind ourselves of what we are trying to find. Our problem says, how many more pennies does Noah have than Kennedy? So we are trying to find the difference of how many pennies Noah has compared to Kennedy. So this difference is what we are trying to find. This amount that Noah has, but Kennedy doesn't. So, how many more does Noah have than Kennedy? I want us to use one of our resources that we've seen in the past. I want us to use our number chart. So here's our number chart. We know that Noah had 10 and Kennedy had 7. So I'm going to underline Noah, circle Kennedy. We're trying to find this difference. How many more did Noah have than Kennedy? So let's go ahead and count. We know that Noah has 1, 2, 3 more. So there is a difference of 3 pennies that Noah has and Kennedy doesn't. So now that we've used this diagram, let's go ahead and label. We found our difference. We know that Noah has 3 more. So there is 3 more pennies that Noah has and Kennedy doesn't. So we found out how many more pennies Noah has compared to Kennedy. This problem is a second grade problem because according to the vertical alignment chart, it states that students will be able to represent and solve addition, subtraction word problems where unknowns may be any one of the terms in the problem. So in this case, our unknown was our difference right here. So this is the unknown that these children in second grade should be able to find. Thank you. I also want to take a second and solve this problem using a strip diagram. Here we have our 2 strips. We know by looking at our information that Noah has 10 pennies and Kennedy has 7 pennies. So if Noah has 10, which is larger than Kennedy, I'm going to go ahead and label this larger set to be 10, which is Noah's. Next, the other set, which we are aware of, is Kennedy's. And Kennedy has 7. So I'm going to go ahead and label the smaller set, which is Kennedy's, to be 7. Next, what we're trying to find is how many more pennies Noah has compared to Kennedy. So this distance right here, this amount of pennies is what we are trying to find. So we know by looking at our hundreds chart again that we found out Noah has 10 and Kennedy has 7. That this distance right here will be 3. So this information can be presented on not only our compare diagram, but also our strip diagram. So, thank you.